Blackhall overview, various valve types that you might see in a dam and reservoir. To put it all in context and to show the extent of the issues we have, there's a bit of an overlay slide on the history of dams, water companies, and valve companies, where I think it will really put everything in context and illustrate what we have to do in the industry. Then we'll going on to the heart of the presentation, BOFIN, and then followed by Q&A after. So, Blackhall, we can trace our roots back to 1828 with the formation in Brighouse of Bladeborough. I'm proud to say my father, who started Blackhall in 1965, was head of research and development at Bladeborough. And in 1989, we purchased the IP for Lionel Johnson and large bore water valves, as well as recruiting their service team to fulfill the obligation for installation, commissioning, and the install base. Again, without dwelling on too much, fast forward to 2007, we purchased and acquired two other valve companies, Shaw Valves and Taylor Valves, principally in other sectors. However, Shaw Valves do have a chlorine valve for chlorine dousing, which again is used in the water sector. Moving on, Blackhall. So what are we about? We're not a conventional and normal valve company. We're not about selling you a valve. We're here to support the valves that we design, manufacture, and repair. So we split this quite simply into our three pillars. The first pillar is all about the likes of Aadil and Aadil's team and our technical expertise, and it's about the skill and the experience of our team who design and support the valves. The second pillar is all about our manufacturing excellence. So we manufacture here in Yorkshire. We are very northern-centric, Yorkshire-centric, proud of supporting local industry, and we have vehemently stayed away from outsourcing overseas, and we're extremely proud of that fact. And then finally, it's last but not least, our ability to support sales after we've supplied a valve. So we've seen ourselves progress over the years into essentially a through life engineering services company, where we can offer engineering services, independent technical advice, training, pretty much what we're doing today, as well as on-site service and in-house repair. And the purpose is to support the valves for life. So that's the end of the sales bit. Okay, nice picture there. These are the types of valves that you would typically find in a dam. So multitude of valves, I'll just rattle through those. We have air valves, we have a Lionel Johnson valve, that's top left. Large bore gate valves, small bore gate valves, butterfly valves, submerged discharge, fixed cone valves, and swing checks. Say if it's in a hydropower scheme, you might have a check valve in the line to prevent reverse flow. That is not exclusive. There's other valves that are found, and we will touch upon those later. Okay, this is I really like this slide because it does put everything in context and illustrates where we are today in the industry. So if you look at the dams and reservoirs in the UK, because I think we're pretty much at the forefront of the experience globally. A lot of dams were built pre-industrial revolution, and that was really for the canal system in the UK. For those that know about the canal system, it was pretty much short-lived due to Mr. Stevenson inventing the steam train. So rapid transport of goods and services uh, basically made redundant the canal system, but we still carry that legacy today. So canals are mainly recreational today, and there's a few hundred dams out there supporting the canal system. Those are the oldest dams in the UK, and likewise, or consequently, I should say, they have the oldest valves in service and the most weird and wonderful valves probably in service as well, which is as a valve person, it's fascinating to see. And then fast forward to the industrial revolution, where there's huge Victorian infrastructure built. So that's the bulk of the build of the dams in the UK were built in that era over those 100 years. And then post-war, very few dams were built. You know, the Victorians built fantastic infrastructure, leading fast forward to today, where you know, there is essentially with the population growth and the demand for water going up, there are a couple of reservoirs which have been approved for build, and I think there's another half a dozen in the pipeline, but not anywhere near the magnitude of the installed base. So as a result, we have the water companies that obviously look after those dams and reservoirs, and over the years, initially the owners of the canal system also own the canals, and then it became a case whereby every little town would have their little water company, the municipality, whether it be Manchester municipality or Huddersfield Waterworks, or and there were every town virtually had their own infrastructure to support the demand for water. And consequently, they all had their own little standards, and the valves that they used were designed and manufactured by companies that would satisfy their individual requirements. So often you get non-standard flanges on, etc. And then post-war, the development of British standards, the quality of valves were very good, and the water companies over those years were more privately owned and government-owned bodies up until 1974, with the privatization of the water companies, which I guess transformed those water companies into non-profit organizations, more into the shareholders wanting a return of their investment. And for me, that coincided with the shifting priorities, should we say, for the water companies into more shareholder focused rather than looking after the assets. So, you know, we've all been to dam sites, and you've seen the old cottage by the dam where the operator used to live, and every day would go into his valve tower and polish the nameplates and look after the valves and operate the valves manually. You know, that I guess that worked for 100 years up until 1974, where that wasn't the case. So we have a situation now where we have older install base, no new valves going to service other than the ones that are being used to replace. And the final part of the jigsaw in this is the three major companies globally, not just in the UK, that are supplying these valves, have prospered and declined over those years. So Guessing Crimes, a fine Yorkshire company manufacturing water valves, they sadly shut the doors in 1998. Glenfield Kennedy, another fine company who obviously still exists today in the guise of AVK, and likewise their install base really high quality. And lastly, ourselves with Blakeborough, who are proud to say we're the only UK manufactured valve manufacturer left standing. So within that rise and fall and the history side, we should be able to see now that the extent of the problem. So we've got about 2,118 reservoirs over 25,000 cumex in the UK, all falling under the Act. So what does the Act say? Under the Act, all valves and piping should be in a good condition. So a bit of a scratch for head. What does good look like? Well, no one can really tell you that. Compounded by the more recent incident at Toddbrook, where it was noted in the Bamford report that poor practice, inadequate maintenance, inadequate surveillance were the root of the incident. And that wasn't just for Toddbrook, I hasten to add, that was pretty much within the industry. So what we're going to move on to is the surveillance side. So BOFIN represents how you put a system in for surveillance. And then preparing for the future, we believe that if you put in good regimes now, then it will satisfy the emerging legislation, which will be coming out in the next few years, where it becomes mandatory to have your valves and mechanical assets in good condition. So BOFIN, what is it? Well, quite simply, it's an acronym. It's an acronym to help the inspecting engineer to assess their valve assets. It's a non-intrusive methodology to assess the valve condition before the operation in a safe and consistent manner. There are other techniques available to us or mechanical engineers that are invasive. This doesn't cover those. So if there's any issues that we come across, then we can put in a camera. We can do ultrasonics on the valve to assess the condition of the material. We can chop off a lump of the flange and send that for mechanical and chemical analysis. That is not what BOFIN is about. This is purely a visual, non-intrusive method. But what it does do is take significant steps towards the compliance of the Act. So B, what does B stand for?
Yeah,
Hello?
so checked out my last MPR that I have is March 2023. So
thank you. B stands for the bolting and the body. And every valve is a pressure containing vessel, and this is the most important aspect of the safety side of the valve. So we've got some pictures there, real life pictures of assets from dams. The first picture on the left shows a discoloration to the body, which is black, and that is actually porous. So the water was coming out of that crack, and that's a pretty serious state of affairs. The middle picture shows evidence of corrosion and wetness. So that indicates that either the bolting is in poor condition, there's a leak from the body gasket, or indeed the casting could be degraded or leaking. So that's another indicator that that needs dealing with. And then on the right is some bolting, some bonnet bolting in a pretty poor state of repair, flaking off. That doesn't necessarily mean to say it's going to fail, but all these pictures here are a perfect illustration of a valve that's been installed for tens of years, doing its job, but could fail catastrophically. Just because it hasn't failed to date doesn't mean to say it is going to fail imminently. So, body, examine the pressure envelope. That includes the body and bonnets and other components that are within that pressure envelope for visible signs of damage, corrosion, cracks. Inspect the surrounding area for signs of leakage. So you may see something which is an indicator of the valve about to fail or needing some form of intervention. especially look around gaskets and seal areas. Bolting, check the nuts and bolts are intact. The bolting, ideally clean it back and have a look for to see it assessed. It may have corrosion on it, but the bolt may still be actually really good. The rule of thumb is as long as there is 1 diameter of thread, then it should be safe. If you're chipping away the corrosion and there's less than a diameter of thread left, then you're putting the bolt under extreme stress. Again, I'm coming to a bit more detail, but again, it's good to know what good looks like. Simple thing for me is, if in doubt, change the bolting. O stands for operating. So how does the valve operate? That's a picture and a drawing of a valve that's actually that is a Welsh water valve, and it looks pretty complex. It is pretty complex. You know, it needs a firm understanding of how these assets operate in order to assess them. So again, the advice is, if you don't know, ask, but don't just proceed to try and open a valve if you don't know how that valve works. So that's an extreme case, and I think there's a picture of that valve in service. That is, the valve actually is designed to sense an increase in flow. So if a pipe ruptures downstream and is burst, then the valve will automatically shut and fail safely. However, when we got to that valve, we did actually find a scaffold, an RSJ actually being put under that lifting weight and rendering it absolutely useless. Next, establish what the original mode of operation was. How is it meant to operate when it was first designed, and don't deviate from that. So you might have a couple of valves in series. They might have bypasses on. So how do those bypasses work in relation to emergency discharge or scouring? If you don't know, find out before you even attempt to operate a valve. Do not operate a valve in a way that it was not intended to operate. You might break something. Also think about what could impede the operation of the valve. So here we've got some other pictures of real life situations. The top left, the green valve, is at Derwent and Howden, and that the little valve on the right, it's called Stevenson valve with a red hand wheel. That little valve there is responsible to open the main big valves, and what that does, it takes the hydraulics from the upper reservoir, takes it into the cylinder on the left, which allows the gate valve to be operated. So unless that's working, the main valve will not work. The picture to the right is a Lonnel-Johnson valve. All Lonnel-Johnson valves have a regulating valve on, which is set on the day of commissioning and is not meant to be tampered with. If it is tampered with, you upset the hydraulic balance of the valve, and you could be in a position where the valve will not open because the hydraulics have been altered internally. So again, find out how the valve operates and what could impede it. And then the other pictures are all illustrations of gearboxes or operating gear that externally has failed or worn. So the bottom left and the middle left, those situations where the gears on the operating gear have failed or broken or worn. The bottom to the right of that, and the black picture with the gearbox on, that was a situation where the valve had seized and someone on the wisdom had decided to put too much force in to try and close it, and it sheared the top of the valve off. You can see on the top hat there, there's a white horizontal line. Well, that's the cast iron is just sheared off due to that. And then the right-hand side is an extension coming up from the valve, which is submerged, and it's clearly not true and vertical. It's at an angle, so there will be excess force required to operate that, and you might even shear or break that extension as a result. So again, do not try and attempt to operate the valve if you see anything like that. So what does the O do? It essentially ensures that the valve is mission capable. There'll be a few new words and terminology that I'm introducing here, but is that valve mission capable? So is it able to operate in an emergency? That's all we're trying to establish here. So quick summary, how does it operate? Familiarize yourself with the type of valve. What was the original modus operandi? What's the duty? Is it scour? Is it emergency discharge? Is it a guard valve? Establish how it works. If there's multiple valves in the line, what is the correct sequence of operation? Very simple one. What is the direction to close and the current valve position? If you don't know that, then you might operate the valve in the wrong direction and you might break something catastrophically. Has there been a modification to the original design? More and more we're coming onto valve sites and finding valves that have had a simple mod. So they put a bigger gearbox on, for example. Now, a valve is sized originally for the design conditions. If the valve has started to get tight and seize up, a non-valve person would perhaps say, oh, this is easy, we'll put a bigger gearbox on. Could be a mistake. So you might be oversizing the gearbox for the internals of that valve, which may cause to again a catastrophic failure. And then finally, what could impede the operation? Okay, is anything broken? Anything seized? What is that safe operating force? So if it's got a hand wheel on, use the hand wheel. You know, don't put scaffolding poles on it to give a bit of extra leverage. And what were the original commissioning settings? Have those been deviated from? So go through this procedure. Your valve should be mission capable. F. So F is all about the functioning of that valve. So after you've checked how it operates, is it fit to function? Is it mission ready? So the O is mission capable, the F is mission ready. So do a pre-test. Are all the safety precautions in place, correct permits, all the stuff that would ensure the safety before you operate that valve? What is the emergency procedure if it goes wrong? You know, are all the personnel well briefed and well trained and competent? Have a look at the maintenance records. Have a look at the former S10 reports. Is there anything in there that would indicate that there is or has been a potential problem with the valve? So the things that we're looking for is, you know, is there evidential data on any noise or vibration or jamming or tightness? If there is, again, be very careful on operating that valve. So now we're proceeding to the actual test. Okay. I would always consider doing a dry test first. Okay, under zero load. So if you've got a, let's say, a free discharge valve, could be a fixed cone valve, or a Lionel Johnson, or even a gate valve in some applications, with a guard valve upstream, make sure the guard valve is closed. Try and operate that valve under no load conditions. At least it will tell you if it's sticking or binding or if it's free to operate. Then proceed. Ideally, we want to test the valve under full load. Okay. Again, you know, there could be issues here with the Environment Agency that might not want a controlled discharge. of a certain amount. So all these things need to be assessed. Proceed to the operation. Are there any unusual noises? If you've never heard a valve operating under load first, you might hear some noise that might be perfectly normal. So when a valve just comes off its seat, there might be a crack as it's coming off its seat as the metallic components are releasing, and then you might go into a cavitation zone in the first 5-10%. It might be rumbling and making noise. That might be perfectly normal, and then you transition through that phase and just observing and noting anything. So you're assessing: is it smooth? Are there any sticking? Is there any jamming? And if the valve is actuated, for example, it might have a manual override. Check that at the same time. Does the manual override work? So in the event of an uncontrolled discharge, and let's say electricity failure, you might want to test in anger the manual override. So don't do it on the day of the incident. Do it at your S10 or your annual test of the valve. And then obviously after the test, make sure all the findings are reported and any remedial actions are noted. And my sort of advice there would be, if you see something, try and do it as quick as you can, because it won't get better. Okay, so let's move on to the I of BOFIN, identification and indication. Okay, is the valve labeled correctly? And what I mean by that is it might have the size, the type, it might say the numbers of turns to operate, the direction of turn. Quite often we'll come to a valve that is down a chamber, but the operating gear is at the top, and you can't identify which hand wheel or which extension is controlling which valve because it's incorrectly or not even labeled correctly. Again, that's quite common. Verify with the historical data. Is the valve that you're about to test, is it the one that's in the historical data? So things get changed over time, and the records are often not up to muster. Especially if it's had a new gearbox or new actuator on, it may not reflect what you're actually seeing. Indication. So this is more in reference to the hardware. There might be an extension with a pedestal, and the pedestal might have an indicator on it. Is the indicator there? I'm missing. I think we've got a picture coming up which showing a pedestal without the indicator on. It could indicate that there's a cause of valve damage. I think that's a typo there, actually, spelling. I do apologise. Ensure that the valve position reflects the actual position of the valve. So you wouldn't want to get to a valve and it says it's partially in the mid position, but it's actually closed. So there we have a remote indicator on the pedestal. The arrow is missing. That would have been a simple sleeve device, a threaded sleeve device that would travel up and down on the stem as that was being rotated. In that site, it just wasn't there. And then finally, we have nip the gland. And the reason we put this in is because the old Syria guide on valves stated that it's absolutely fine to see a leakage from a gland. You don't need to do anything about it. Absolutely, totally wrong. I'm pleased to say that Aadil was on the panel that revised the new Syria guide. That has been put right in the new guide. If there's a leak, it needs to be fixed. There's no leak that I'm aware of that mends itself over time. I think the old guide said, oh, it'll silt it up and it'll be fine. Well, no, it won't. It will leak and leak and leak. And what happens there is you get a condition where you get erosion of the stem, and once the stem is eroded, then you have a huge expense of taking the valve out, having to replace the valve, when all you'd have to do is nip it up fairly easily. The graphic in there shows a conventional gland. If you might be turning up to a site where it's not a Blackhall valve, or it's not an old installed quality valve, the new framework valves just have an O-ring in. If that is leaking, then sadly the asset is substandard, and you'd probably have to replace the valve, or certainly take the valve out line to replace the O-ring seal. So just beware that if you see a new valve on site, doesn't necessarily mean that it's a long life product. And if there is a leak, do something about it. So there we go. If left, it will only get worse. So in summary, BOFIN, remember BOFIN. Bolting, operation, function, indication, and nip the gland. Always use BOFIN. You can actually use BOFIN. It doesn't have to be a valve. It could be a piping, any pressure vessel you could use it on. What does it do? It does establish a robust surveillance and inspection regime. It forms the basis for creating a good valve maintenance and asset plan. If in doubt, final plug, if in doubt, contact us. We're here to help, and be glad to do so.